Okay, let's do the sixth question. Okay, now this is also in the division form or the quotient form. You can use u upon v method. Now see, before using that, let's simplify this a little bit so it will become a little bit easier for us to differentiate. Okay, so see, let's find the LCM for both of this. Okay, for the numerator and denominator. So this will be x and 1 upon x and x 1 times b1. Okay, and this will be x, the geometry LCM, so 1 x times x minus x 1 times 1. Okay, now you see we can cancel this both and it becomes x plus 1 upon x minus 1. Okay, so we have changed the function to this form. Okay, x plus 1 upon x minus 1. Now derivative of this, d by dx of this. Now you see, now this will be a little bit easier. Okay, so considering this to be u and this to be v, the formula is u dash v minus uv dash upon v square. Okay, this is it, uv whole dash is equal to this. So let's find out u and u dash. Okay, u is equal to x plus 1, so which implies u dash will be derivative of x plus 1, which will be, now see, derivative of x will be 1 and derivative of 1 will be 0. Okay, because it's a constant, so you have 1. Okay, this is u dash. Now v is equal to, this is v, x minus 1 implies v dash is equal to derivative of x minus 1. So the derivative of x will be 1 minus the derivative of 1 will be 0. Okay, because this is a constant. Okay, so we have v dash is equal to 1. Okay, v dash both are 1. Okay, now let's put these values in the formula, so which implies, so u dash is 1 upon, sorry, multiplied by v is x minus 1 minus u is x plus 1. Okay, and v dash is 1 upon v square, x minus 1 whole square. Okay, so now see, x minus 1 into this will be x minus 1 and this multiplied 1 will be x plus 1 upon x minus 1 whole square. Now removing the brackets, we have x minus 1, this will become minus x minus 1 upon x minus 1 whole square. Now you see, this is positive x and this is negative x, this both get cancelled, so you have the remaining minus 1 and minus 1, which is minus 2 upon x minus 1 whole square. Okay, so this is the answer. Okay, now let's do the next one, that is the seventh one, which is 1 upon ax square plus bx plus c. Okay, now you see, this also can be differentiated using the u upon v, considering this to be u and this to be v. Okay, but you see here it's just a constant, we don't have any x functions. Okay, or any variables of x. Okay, so it's easier we convert this to the x power n form. Okay, because since we don't have any variables or x functions here in the numerator, so this can be converted as, if you take the denominator to the numerator, it will become ax square plus bx plus c. Now see, this one, this whole is power 1, so it will go, when it go to the numerator, it becomes negative 1. Okay, so this, the function is changed to this form, so the derivative of this will be, now we see we have the formula derivative of x raised to n, the power rule, which is n x raised to n minus 1. Okay, but you see, this is actually not x, if this is in place of x and this is n, but actually this is not n, sorry, not x, we are assuming this to be x. Okay, so what we do then, we use the chain rule here. Okay, that is, now derivative of this, assuming this to be x and this to be n, then n multiplied by x. Okay, assuming this to be x, n x raised to n minus 1 minus 1 minus 1. Since we are assuming this, by using the chain rule, we have to differentiate this again. Okay, and multiply it, so d by dx of ax squared plus bx plus c. Okay, so this becomes minus 1 ax squared plus bx plus c. Minus 1 become minus 2. So derivative of each, d by dx of ax squared plus d by dx of bx plus d by dx of c. So this can be written as, you can take this, now you can bring this to the, or take this to the denominator. Okay, so it become minus 1 upon ax squared plus bx plus c whole square. The negative power will become positive. Okay, multiplied by, now the derivative of ax squared will be, a is constant, and the derivative of x squared will be 2x squared in this form. Okay, 2x raised to 2 minus 1 plus the b will be out, so the derivative of x will be 1, so b into 1 plus the derivative, this c is a constant, it will be 0. Okay, so this can be written as minus 1 upon ax squared plus bx plus c whole square. This can be written as 2ax raised to 2 minus 1 is 1. Okay, plus b into 1 is b, or this can again be written as minus 1 into this will be 2ax plus b upon ax squared plus bx plus c whole square. Okay, that's it. This is the answer.